So 2.4 also includes finding angles in a triangle. So let's take a look at a triangle. So here's a triangle. Okay. And in the triangle we have angles. So there's an angle 1, an angle 2, and an angle 3. And we have a specialized formula for that that says that if you take angle 1 and add it to angle 2 and you add it to angle 3, then it always equals 180 degrees. And that's true. You can do this at home. You can take and draw a triangle on a piece of paper, and don't make it too big. Just make it a normal size, not too small either. And if you cut the angles off with the scissors and you line them up, you'll discover that the angles will do this. You'll have angle 1 here, angle 2 here maybe, and 3 here. But you create this straight linear line, which means that, hey, if you were to measure with a protractor from here to the other side, is the 180 degrees. And that's true for all triangles. So if you try that out at home, you'll find that that works. But anyway, since we know that, we could be given two angles and then solve for the third. So let's say that angle 1 was 20 degrees and angle 3 was 100 degrees. So if we put those into the formula, we could actually solve for angle 2. So we have 20 degrees plus, I don't know what angle 2 is, plus 100 degrees equal to 180. I could add the numbers because they're on the same side. So that's angle 2 plus 120 degrees equal 180. And now I can subtract 120 from both sides. And so angle 2 turns out to be 60 degrees. And so I can do that. And that's a really neat formula for me to find any angle inside a triangle if I know at least two of them. Now, another situation is we could take a same triangle. Let's say it was, we'll do something like this. This is a really unusual triangle. Okay, so here's my triangle. And this time, I'm not going to tell you the angles. I'm going to say that, hey, for example, this angle here is x, and then this angle here is x. And then I want to know also that this is going to be, let's say, 2x. Well, I'm not telling you any of the angles, am I? But we could still solve it because we can take our variables x angle plus x angle plus 2x angle, and that has to still equal 180 degrees. So I add all my x's together, so that's 1x and 1x and 2x makes 4x. So that's 180 degrees. Now I can divide by 4, and so x is what? 45 degrees. And so now I know these two angles that were the same are 45 degrees. And then this angle here is 2x. And so that's supposed to be, so I have to go 2 times 45 equal to give me 90 degrees. And so now if I add the two other degrees together, I still get 180 degrees. And so that's interesting that this still comes about. Okay, but again, the 2 times the 45 is 90 degrees, and then if I add the other 2 degrees that I have, then I get 180. And so this is the situation that we come up with. It's our specialized formula for angles. The next thing that we want to look at is finding circumference and area of a circle. So let's take a look at a circle and make sure we know all the parts of the circle. So here's my lovely circle. Let's try that again, see if I can get a better circle here. Here's a better circle. Okay, we have a center. When you go from the center to the edge of the circle, we call that the radius r. And so radius is what will be r. If you're going through the edge of the circle, through the center to the other side, to that edge, then that is called the diameter. Okay, so diameter. So I'll just extend it. And so from here to here is the diameter. And so diameter is actually 2 times the radius, because there's 2 r's, 2 radiuses, to get from one edge to the other. And so these are important pieces to know. And then to know the formula for circumference, circumference is going to be 2 pi r. And so we'll basically, in the homework and quizzes, we'll pretty much say that pi is 3.14 is what we're going to go with for our standard constant for pi. And so if I was to put values in to calculate circumference, let's say for example the radius is 3 inches. Okay. So then I put it into the formula for circumference, and circumference is 2 times the pi times 3 inches. And so this is my value, so I go ahead and multiply the 2 times the 3, I get 6 pi inches. And notice again, for circumference, this is also a distance. And distance for circumference is basically saying, hey, if I pick a point here, and I travel all the way around the circle, that's the distance we call circumference. And so in this case, this will be 6 pi inches. Now this is called an exact value because pi is left in the equation. If I want to get it to be rounded, then I have to take 6 times 3.14, and now I multiply that. And so if we calculate that on our calculator, if we go ahead and take 6 times 3.14, I get 18.84 inches. Okay, and so this is a rounded answer, because they may on the homework say, okay, round this to the nearest tenth, and so I rounded to 18.8 inches. And so this is my circumference. Now to calculate area of the circle, okay, then we need to have another formula, which is a specialized one. It's area equal to pi r squared for a circle. So now if we have a circle again, and I say that the radius is 3 inches, then I can put that in, pi times 3 inches squared, and so that becomes 9 pi inches squared. And so this is my area, which is exact. It's an exact value because I've left pi in. Now if I want to get a rounded value, I would take out the pi and put in 3.14, right? And so I would multiply that out. So let's do that. So grab your calculator and let's calculate that. So that would be 9 times 3.14, which turns out to be 28.26, and that is in inches squared as well. Now this is going to be rounded, so let's say we're still rounding it to the nearest tenth, so that would make it 28.3 inches squared for area. And so these are the only 2 formulas that we use for the circle. And we do circumference and we do the area for that.